Let's look at this interesting topic called differentiation. Now, differentiation is the instantaneous change of a function with respect to one of its variables. Okay, if we have, for example, say y is equal to a function of x, okay, as x is changing, how is y changing?
For more videos, please click on the subscribe button below. I need your comments as well. Thank you.
For example, you have y equal to x squared plus 2x plus 4. This is a curve, okay? It's a quadratic function, okay? And anytime there is a change in the value of x, you will have a corresponding change in the value of y. And this is what we call differentiation, okay? Let's go ahead. Let me explain them more. Yeah, and you still remember the equation of a line. So for a straight line, the rate of change of y with respect to x is constant. This is a straight line, okay? So the slope or the gradient of a line is always constant as long as it is a straight line, okay? So for a straight line, the rate of change of y with respect to x is constant, and it's called the gradient of the line. Remember this equation of a line, y is equal to mx plus c, where m is what? Is the gradient, okay? C is the intercept on the y-axis. But in the case of a curve, the rate of change of y with respect to x is not constant, okay? The slope or gradient of the curve at any point is the slope of the tangent to the curve at that point, and it's what we call the derivative, which is the dy dx, okay? So the slope of this curve, for example, at this point is different from the slope at this point, different from the slope at this point, different from the slope at this point, different from the slope at this point. So the slope of the curve at any point is what we call the dy dx, the derivative, okay? Derivative of the function. This is a quadratic function. You can say it's f of x y equal to f of x, okay? The same thing here is y f of x, but the equation of this line, okay, is a straight line. The highest power of x here is 1. Highest power is 1. N is equal to 1. But here for a quadratic function, n is what? Is 2. Okay? If it's going to cross the x-axis at 3 points, then your n will be equal to 3. Okay? So at any time there is a change in the value of x, let's write a function, for example. You say y is equal to, let's say, x squared plus 5x plus 2. Okay? Like this one. It's a quadratic function. Okay? So at any time there's a change in the value of x, let's say if x was formerly 1, from x1 to 2, that change, the corresponding change in y is what we call differentiation. Okay, and when you find the differential value or the derivative of a function at a given point, that is the slope of the tangent at that point. Okay, if we draw a tangent to this line at this point, okay, this point here, the slope of this tangent will be the slope of the curve at this point. So that's it. That's what differentiation does. It also talks about the rates of change. Let me show you the next picture, this diagram. Now, here is another explanation for differentiation. It talks about the rate of change. So the change in y, okay, if you have a function that is y equal to f of x, the change in y, okay, with respect to x is what we call the slope or the gradient of that function, okay? Now the change in distance with respect to time is what we call velocity. Change in velocity with respect to time is what we call acceleration, the rate at which you are increasing your speed, okay? That's what you call acceleration. If you are pouring something into a container, or you are pouring something out of the container, then the change in the volume of fluid, okay, with respect to time, is what we call the flow rate. That's what we call flow rate. And also, even in your finances, the rate at which the prices of goods and services increase, okay, with respect to time, is what we call inflation rate, and so on. This is what we refer to as differentiation, measuring the rate of change of two quantities, okay.